In a lot of the problems involving latitudes and longitudes for your exam, you're going to be interested in finding distance along a line of longitude. So I'll just draw one here. And the key thing you need to know how to do is just form sectors. So imagine you have a point here on this line of longitude, and you have another point B on the same line of longitude. One will be interested in finding the distance between point A and B. So you can imagine a point, let's say a plane, an aeroplane is at point A and it flies to point B along this line of longitude, and you're interested in finding the distance. And you know that this is essentially an arc because one can form a sector by joining the center of the sphere or the earth to point A and the center of the earth or sphere to point B. And what we have is a sector. So you have something like this. It's point A, point B, and the center. So what's the length of the arc from A to B? I'll call that S. There's an angle formed at this center, and you know that the length of an arc, because we've covered this in the video dealing with length of arcs, is given by theta divided by 360 times 2 pi, the radius of this sector. And I'm going to put big R here. Why? Because from the center to any point on the surface is equal to the radius of the earth, and that's big R. So just take note of this. The distance from the center of the earth to any point on the surface of the earth is equal to the radius of the earth, which is big R. So the sector I have here has such that the length of this side OA and OB is equal to big R. So the length of this arc, S, is theta over 360 times 2 pi r. So all you literally need to know, because you know that R is 6,400 kilometers, pi is 22 over 7 approximately, we have 2 here, 360. All you need to know is the angle formed here. And how can we determine that angle? All we need to know is the latitude of point A and point B, because if you know the latitude of point A, you know the angle formed here, because imagine there's a point directly below A here. The angle formed between line O, I'll call this Q, OQ and OA, you know that angle is the latitude. Same thing for this angle here. You can find this angle as the latitude of point B because it's the angle formed between point O and a point directly below B. Let's assume Q is also directly below B. So formed between OQ and OB. Now I say directly below B, but it's not below, it's clearly above. So a point directly above B, in this case, because B lies to the south of the equator. So I meant to say the angle formed between OB and OQ. This angle here is known. So once you know this angle and this angle, you know the total angle, and you know this theta, and you're able to find the length of the arc. And that's how you find distances along lines of longitudes. So what I just demonstrated is going to be useful. So let's move on to the next. So we're interested in finding the distances along lines of latitude. So I could say distances along lines of latitude, or the distance along a line of latitude. So I'll draw a line of latitude. This black line here. And you essentially cut through this plane, the plane of this line of latitude. Find that it has a center somewhere here. I'll call that center O. I'll call it O. So let's have 2 points on the same line of latitude, point A and B. I can join O to A and O to B to give a sector that looks like this. If you look from the top, this is what you see. Assuming you can see through the sphere and you look from the top, this is what you see. Sector OAB with some angle formed in between. Now, let's say this is the prime meridian, different color. Say this is the prime meridian, and this is the point on this latitude that also lies on prime meridian. I'll call that point, call it P, and I'll locate that point here. Now, as you move from P to A, there's an angle formed, and that's this angle here. And as you move from P to B, there's an angle formed as well, and that's this angle here. And as you know, if I call this angle theta 1 and the other theta 2, you know that theta is the longitude of point A. Remember, the longitude is the angle traversed when moving from the prime meridian to the desired point along the same plane, and the angle formed at the center of the sector essentially is the angle that is traversed is the longitude of point A. Same thing for point B. You have to move from the prime meridian to point B along an arc on the same plane, and the angle traversed is the longitude of point B. So the longitude of point B is theta 2, longitude of point A is theta 1. But the key thing I'm trying to stress here is that we want to find distances, and you can find them by using this sector we just formed, because the distance AB, I'm going to call that S, AB, that distance AB is the length of an arc, and it's given by the angle formed center of the sector, which now I'm just going to combine. Let's do this. I'm going to combine. So I'm going to call this angle, well, I'm going to call this angle theta. So the combined angle is theta at the sector, and length of this arc AB is given by the angle theta divided by 360 times 2 pi times the radius of this sector, which is small r. Why? Because the radius of the sector is the length of the line from the center to point B on the surface, or from point A to A on the surface. Remember, the top view, when you have a top view of this line of latitude, what you have is a circle. This is the center of that circle, and the radius of that circle is small r, and it's given by the distance from the center to any point on the circumference. Point A and B, well, point A is somewhere here, and point B is somewhere here. So line from point O to A and point O to B has a length that's equal to the radius of this circle, and this radius is small r, so hence why it's small r. So be careful, because when we were looking at distances along lines of longitudes, the radius of the sector we formed is actually equal to big R. So be careful, because there's a distinction. Be careful, note this distinction, because this can cause a lot of problems in exams, but just note this. It's very useful to note this. So other than that, we now know how to calculate the distance along a line of longitude. You just have to form a sector, and you find the length of the arc, and you just have to be careful with the radius you use. That radius is small r. Now remember, what's a small r? Small r is equal to r, big R cos theta, where theta, actually I'm going to call it alpha, and that angle is the angle that is formed when one draws a line from the center to, say, a point on that latitude. It's the angle from between that line and the line from when you draw a line from the center of the sphere to a point directly below the point on the latitude. Is this angle here. So I'm going to call that alpha, because I've already used theta. So it's that angle here. So essentially this angle here is always the latitude of point on the line of latitude. This angle here is always equal to the latitude of point on the line of latitude that the point you're interested in lie on. It'll make more sense when we try out examples, but just keep all this in mind. So you can see that we're using this relationship. It's going to prove very useful. I'm using alpha instead of theta, but you know that this angle is a latitude.